So we're going to solve for C1, C2, X and Y components of the two forces, right? And so this is a scenario right here. A boat is being pulled upwards by two cranes at various angles. 35 C1 and 40 degrees for C2, alright? So we're going to use Lami's formula, or Lami's equation to solve this. So first, let's find C1 and C2 by using Lami's formula. Alright, so the first step should do is to do what? What's the first step we should do? Draw a free body diagram. Beautiful. Alright, so the free body diagram is just a point, and then we have a downward force. The downward force here is what? 800 newtons. And then we have two other forces applied, which is C2 and C1. Excellent. And they're going upwards. Now, something very important to remember is that the total forces going in the vertical direction upwards equal the total force that going what? Downwards. So the y components of C1 and C2 must equal to 800. Alright, so bear that in mind. Alright, also once applying forces or any free body diagram or vector, we should always remember that x and y components are what? X and y components are what? Independent of each other. Great, excellent. Alright, so let's now work this out. So based on this diagram now, we should have here this being what? 40 degrees, and this being 35 degrees. So based on Lami's formula now, we know that C1, before we go to that, let's work out all the other angles in between. So let's find the angle here. For this straight line, the total angle is 180, right? So the angle right here is going to be 35 plus 40 minus from 180. So this is going to be 180 minus 75, right? Okay, so the angle right here is going to be 105 degrees. Alright, so the angle right here now, let's work this one out. So the angle right here, from here to here, it will be this plus 90. So this will be 90 plus 40, give us 130 degrees. The angle right here between C1 and 800 is? So it'll be 125. So it'll be 90 plus 35, which equals to 25 degrees. So now we know our three angles. 105, 130 degrees, 125 degrees, right? So let's find any of the unknown forces by using Lami's formula. And Lami's formula is, say that the sine of any of the angle is equal to the sine of the angle between the two other forces, right? So therefore we're gonna say C1, and C1 angle is what? What's C1 angle? C1 over sine what? 130. 130, because the angle between the two forces C2 and 800 is 130. So looking at C1, the angle between the two other forces is 130. So it'll be sine 130 degrees. And it's equal to C2 over the angle between the two other forces, which is between C1 and 800. So therefore that is what? 105. So that is sine 125 degrees. And that is equal to the 800 newtons that we know over the angle between the two other forces, which is 105. So the angle between C1 and C2 is 105, so it'll give you sine 105 degrees. Alright, so we can use any part of the equation to find one of the unknown, right? So let's find C1 first. So to find C1, we're going to use this one to say C1 over sine 130 degrees is equal to 800 newtons over sine 105. Alright, so to get the closest possible correct answer, the best thing we could do is to cross multiply and then we divide by the 105, sine 105, right? So make that kind of get more of a more accurate or closest to the accurate answer. So we're going to say C1 equals to sine 130, correct? multiply by 800 newtons all over sine 105 degrees. And so C1 equals to, what C1 equals to? 634.45 newtons. Alright, let's put this up here one time. So the C1 is equal to 634.45 newtons. Alright, so we have that force. Alright. So now we're going to find C2. Okay. So now let's work out C2. And all we're going to take is part of the equation, as we did before, and say that C2 equals to what? So we'll take out this part, that C2 over sine 125 degrees equal to 800 over sine 105 degrees. So again, to make C2 be the subject of the formula, we're going to say that C2 equals to sine 125, right? Multiply by 800 newtons all over sine 105 degrees. That equals to? So C2 equal to 678. Flat?
No, 0.3.
Point? 444. Alright, newtons. Alright, great. Or 39, that's fine. Once it's very close to that, that's fine. Round off early or late, we'll give a difference in value. That's not a problem. So let's put this up here. So it's going to be, let's say, 678.44 newtons. Alright. So again, a point to note that these two values are pretty much close because the angles are close. Okay? It's 5 degrees difference. Alright? So the values will not be greatly different. Alright, but let's look at how to find the x and y components of each of the forces. And remember that x component is always sine of the angle, right?
Yes.
To find the y component is sine of the angle, and to find the x component is cosine of the angle. Okay. So y, just remember, y is equal to sine of the angle, and x is cosine of the angle. Alright, so that's simple. We should be good at that. So let's do C1 first. So let's do C1, and we're going to do C2 simultaneously. And let's look at x and y. Let's do it like this, alright? To make it easier. So, for C1, the angle is 35 degrees. So we're going to say now for C1 it's going to be, let's define x, going to be cosine of this, right? So what is the force? The force is 634. So it's going to be the force multiplied by that. So we're going to say now 6, going to be 634.45 cos what? Cos 35 degrees. And that equals to, what's the value here? 519.71 newtons. Beautiful. So let's go to the x component of C2. And C2 angle is 40 degrees, and the force is 678. So let's say 678.44 cos 40 degrees. And that equals to? What that equals to? 519. Okay, 519.72 newtons. Alright, excellent. Let's get the y components now. The y components, remember, we go with the force multiplied by sine of the theta, right? Alright, so remember that the force, whatever force it is, we're going to multiply it by that. Alright, so, and let's just put y there, the y force, and this will be the x force. Alright, so whatever the force of the hypotenuse is, that's what we're going to use. Alright, so for C1, it is again 634, so it will be 634.45 34.45, and we're going with sine, so it'll be sine 35, right? Sine 35 degrees, and that equals to 363 point anything? 0.91 newtons. Excellent. All right, so let's go with the x now, with the C2. So C2y will be 678.44 sine, the angle is 40 degrees, and so that is equal to 436 point 80. Oh, 08, that's fine. 08 newtons. Alright. So we're going to do one more thing. We're going to prove that the total upward forces equal the total what? Downward forces. So the sum of y, the sum of the y forces must equal to what? 0. And the sum of the x forces must also equal to what? 0. Because the entire system is in equilibrium. Okay? So let's do it the y first. The y from C1 and C2, they're both going upwards, right? And the 800 going downwards. So C1y plus C2y must equal to what? 800 newtons. Must equal to 800 newtons. So what we're going to do now is to add these two values. If we add these two values here, the two y's, we should get what? 800. But they're not going to be exactly 800. Why? Because round off values, right? But given the value to get right here, it should be very close. What this value is? 700 and what? 99.99 newtons. So it's pretty much close. There's a round off problem, but yeah, that's correct. So now we're also going to prove that the force is in the x. So the force is in the x, so that's C1x and C2x going away. They go in opposite direction, the same plane, so one must be positive, one must be what? Negative. So this one will be a negative value, this one will be a what? Positive value. So we can say C1x, which is this one, is actually what? Negative. And this is a positive value. So if we add these two values, we should get what? 0. So negative 519.71 plus positive 519.72, which is pretty much a close answer again. Round off issue to get a point 7.1. And so definitely these two values give us what? 0. So the sum of x is equal to what? 0. Alright, so great job. Alright, so look forward for the next question. See you soon.